Well, let's review how to isolate one variable from a given equation. For example, if I were to solve for y in this equation, my y is part of the domain, the domain, my God, of the denominator. So just to get rid of the fraction, perhaps, of course, the LCD, in this case, we can multiply by y plus 3, y plus 3. Here, of course, it eliminates. So now we have y plus 3 times x equals 7. In this case, we can do two things if I were to isolate the y. Route 1. Of course, we can divide by x, and we have y plus 3 equals 7 over x. And now, of course, we can subtract 3, and we are done. Y equals 7 over x minus 3. That's one way of doing it. The other way would be to distribute the x, and that's what I'm going to do now. Let me erase this. Both methods are correct. I prefer to distribute because in some cases you must distribute. In some cases you may distribute or you may divide by x. So in that way I can always distribute the x and that's it. So if I were to distribute this one, that would be xy plus 3x equals 7. Of course, since I'm isolating the y, so I need to leave all the terms that contain the y, in this case on the left, one side of the equation. I'm going to subtract 3x, xy equals 7 minus 3x, and now we may divide by x, and voila, our job is complete. Y equals 7 minus 3x over x, and we're done. Let's try this other one. Same thing, fraction, so we can multiply by the LCD, 5y minus 1, here 5y minus 1. So this over this simplifies, so we have 7 equals 5y minus 1 times 2x. Now we may distribute. Notice if I were to divide by 2x here, it gets quite messy, and then I add the one that I had to divide by 5. So we end up with the complex fraction. Okay, so this is why I prefer to always distribute, so I don't have to think when can I not. So this time that would be 10xy minus 2x equals 7. We may add the 2x, then xy equals 7 plus 2x, and of course I can divide by 10x. Now we have y, therefore y equals 7 plus 2x over 10x, and we're done. Same old fractions, so let's go ahead and multiply by the LCD. Let me just erase this portion here. So the LCD here will be 8y minus 9 times 8y minus 9. So this over this eliminates, equals to 1. So what do I have? 8y minus 9 times 3x equals what? 7y plus 5. So let's distribute. 8 times 3, 24xy, plus or minus, this was a minus 9 times 3, 27x equals 7y plus 5. Okay, notice here that I have 4 terms total. This one has y, this one has y, so I have to have all the terms that contain the variable, in this case the y, one side of the equation and the rest on the other side. Yeah, so you have, this is positive, negative, positive, positive. So I recommend that when you, in this case, the y, the terms that contain y can be on the left or on the right. It doesn't matter. We get the same answer. However, try to always minimize the number of quote-unquote negative terms. For example, if I want to, or if I want to move the y's to the right, so this one becomes negative here, and the 5 becomes negative on the left. So I'll end up with negative 5 minus 27x equals 7y minus 24xy. Three terms will be negative. So in this case, it's better to have the y's on the left-hand side. So we subtract 7y. We have 24xy minus 7y equals 5 plus 27x. Yeah. And why do we want all the terms that contain y one side of the equation? Because now we can factor the variable. Notice that it has 24x times y, 7 times y, so I can factor out the y. Oops, so factor out the y, so I end up with 24x minus 7. In other words, factor out the y. So I have x, 24x minus 7. Oh, since the goal is to isolate the y, go ahead and divide by 24x minus 7. And our job is done. Therefore, y equals 5 plus 27x over 24x minus 7. We are done. So notice that they are almost not the same steps, but if I, of course, you have the fraction, your LCD will take care of the fractions. You may want to then break the parentheses and divide accordingly. Now, if you have more than one term that contains the variable, then you have to do the dancing, moving the terms. So all the terms that contain the variable is one side of the equation, you factor, and then you divide. No need to factor because I only have one term with the variable in this case, so there is no factor that is required. But since I have more than one term with the variable, I must factor out that variable, and then we divide. Hopefully this helps. Thank you.